This is about a privately owned company called Carbon Engineering. Carbon Engineering is an independent Canadian company based in Squamish, BC, Canada. It was incorporated in 2009. Some of the investors of this company include Bill Gates and Murray Edwards. This video now talks more about Carbon Engineering, who they are, and what they do.
Direct air capture technology employs a proprietary process that allows its plants to capture and then use the carbon dioxide previously emitted into the Earth's atmosphere.
This is very different from traditional carbon capture and storage. Air capture absorbs carbon dioxide that's already been emitted. This seems to be one of the only feasible ways of trapping emissions from small mobile sources like cars, trucks, and planes. Emissions that represent 60% of the total today, emissions that are likely to increase in the future. Of course, trees do the same thing, but studies show us that planting enough trees in the numbers needed would require diverting vast amounts of agriculturally productive land. But capturing carbon dioxide directly is feasible. That's already happening at Carbon Engineering's prototype contactor at the University of Calgary.
So this is our prototype air contactor. This is the smallest module of what will eventually be multiplied up many times to form our full-scale system. I'm standing at the inlet, so air containing CO2 enters here. And roughly speaking, we need about this kind of area to absorb the emissions being created by some car or truck somewhere else. Now with this full system, we're absorbing emissions from about 14 or 15 vehicles. And we're using a lot of the stuff inside here that we've borrowed from other industries and other uses. But in each case, we've tailored them and re-engineered them for our purposes here. Now inside this device, we've got two main things happening. We've got air flowing in this direction, then we supply our CO2 absorbent liquid to the top so it flows down with gravity. And where they meet is right in the middle of the device that's filled with all these tightly corrugated PVC sheets.
Every single surface inside the stack is wetted with the carbon dioxide absorbing solution. Air containing CO2 flows over these surfaces, and when CO2 molecules encounter the liquid, they're converted to carbonate. The geometry of the packing material ensures that as much of the liquid as possible is exposed to the passing air. It also disturbs the flow, creating turbulence, so most of the air streaming through actually makes contact with the solution. The net result? Carbon dioxide is trapped in solution for further processing.
This material's great, but one of my jobs is to make it even better, and we're making good progress on that. Now we'd open this up for a look inside, but we're capturing CO2 with it right now. And by the time we get to the outlet here, where these fans pull the air through the contactor, over 80% of the CO2 has been removed. We're trapping over 100 kilos of CO2 here every day, and that CO2 gets absorbed into our solution and forms a type of carbonate salt. With our full-scale system, we're not just going to leave it at that.
The next step is to get back the carbon dioxide from its carbonate salt. Carbon Engineering is doing that using paper industry technology already proven at large scale, but they're testing a membrane-based system that should consume much less energy. Either way, the capture solution goes back to the contactor, a stream of pure compressed carbon dioxide is generated, and any CO2 produced during the separation process is part of that stream. There's almost no new carbon dioxide released. This prototype represents a tiny segment of the full design. The internals of this 100 kilogram a day unit will do the same at large scale and can be replicated 10, 100, 1,000, even 20,000 times. At that scale, emissions from 300,000 cars could be captured every year without significantly changing the technology of the Carbon Engineering prototype. The prototype is building confidence that air capture can be done efficiently and cheaply. There are significant advantages to building scaled-up air capture installations. Today, carbon dioxide itself is a valuable commodity, but here's a very attractive future scenario. Combine captured atmospheric carbon dioxide with hydrogen generated from water using renewable energy. Hydrogen itself can be used as fuel, but that requires a whole new transportation infrastructure. But combining it with CO2 from air capture could produce hydrocarbons like gasoline and jet fuel. We're already set up for them, and when these fuels burn, they would simply release their carbon dioxide back to the atmosphere from where it came. This would be sustainable and the long-run cost for providing the CO2 for these.
By displacing the world's fossil fuels, carbon engineering hopes to significantly reduce the emissions currently created by transportation. The direct air capture and air-to-fuels technologies detailed in this video are currently being demonstrated at CE's headquarters in Squamish, British Columbia. By 2020, carbon engineering will begin its commercial implementation of this disruptive solution to the world's greatest challenge.